Hello and welcome to our final session of the Modern Hydronics Summit 2021. This is the reveal of the winners of our first ever Sweet Heat contest. I'm here with our finals judges, John Siegenthaler and Robert Bean, Siggy and the Bean. Guys, thanks again for joining us and for taking part in this Sweet Heat contest. As I said, this was our first ever Sweet Heat contest where we were inviting contractors from across the country to send in projects. We started the contest late fall of 2020. We received 31 entries in total from British Columbia, Alberta, Saskatchewan, Manitoba, Ontario, and Nova Scotia. Overall, we had 11 commercial projects and 20 residential installations that were submitted into the contest. The winners, just so everyone knows, the winners of this contest will be featured in the fall edition of the Modern Hydronics supplement within HPAC magazine. That will be coming. That comes out in late August. So look for that. Because of the number of entries we received, we ended up doing two categories: a winner for the commercial and a winner for the residential categories. And we've also named two runners up in each category. And again, our finalist judges who are here with us today to help us with this final reveal, John Siegenthaler and Robert Bean. Well, I don't want to hold this up any longer. We want to get to our winners. So let me commercial category. Robert, I'm going to hand this to you. The runner-up in the commercial category, Rambo Mechanical Solutions from Brantford, Ontario.
Thanks, Doug. Yeah, so as we were going through these, the runners up and the winners, we do want to point out, earlier on we were talking offline just how great the entries were. And both John and I, of course, were impressed by the workmanship, which is awesome to see. And we also want to draw attention that although workmanship is a big part of our assessment, between John and I, John, 80 some odd years of experience, something like that. We've seen a lot of really good jobs, a lot of crappy ones too. So we're certainly thrilled to see the quality of the workmanship, but we're also, after 40 years, looking for other things too that are becoming more important, or equally as important, I should probably say, to the quality of workmanship. And that has to do with the application of engineering principles that promote not only conservation of energy, but energy efficiency, and also compliance with standards. And certainly that we would like to see in these competitions, that submittals, the contractors that are submitting this work, that you're actually, if you're going to be stating that you're efficient, well, to what standards are you referring to? And tell us how you have, or demonstrate what the efficient applications are. What did you apply that make the system efficient? If you're going to be comfortable, or you're saying that the systems are comfortable, well, what standard are you saying that you've designed to? So we want to hear things like that. It's compliant with ASHRAE 55, or it's compliant with a LEED standard, or net zero energy. So as we were going through these, so John, as you know, this first runner up was a landscape farm equipment building, about 30,000 square feet. And the things that I personally liked about this, again, was the application of multiple boilers staged, rather than putting one large device in, the multiple ones with all high efficiency, and staging them. And by doing that with connected to large surface area heat exchangers like the radiant and the snow melting, then you can get these really low temperatures coming back, and then the mechanical systems operate as the engineers intended, at the manufacturer. You get these engineers that specialize in combustion and heat exchanger design, and of course they want their devices to condense all the time. And so I really like that. I like the fact that they used some innovative products in the tubing systems that were one of the manufacturers provides. I like that concept as well. And same thing with the selection on the circulators. Again, John, you can address the circulator wire to water efficiency. How many gallons are we moving for the watts that we're using is important. So that's why these guys got the runner up. And John, do you have any comments on that one?
Well, just to echo what you're saying, the good use of modern materials, obviously metal pipe, copper pipe in particular is getting pretty expensive. They're working with the polypropylene pipe here. I like the common venting that it, certainly simplifies the amount of vent piping that goes in there. Yeah, those are all ECM circulators. They're definitely going to have a lower power consumption. Not sure if those are tied in with any speed control function in the boilers or not. But one other thing that struck me on this too, and it's a point I try to make with any system, you see that the controls here have been separated from where any potential water leakage could occur. And I'm sure many of you have seen projects where you'll see piping, valves, air vents, and so forth. And somewhere there's a little spot on the wall, and they drop in a $500 microprocessor-based controller, and it might end up right under a circulator, it might end up under an air vent. And if everything works perfectly, that's not a problem. But when something starts to leak, obviously we don't want water coming down into those controls. And you see here in this lower right photo that they've set up a really nice control panel. They can sit there and basically control the whole system or change settings on the system. And it's separated away from where the water portion of the system is. So that's a nice design concept that you can apply in pretty much any residential right on up through a commercial system like this.
Awesome. Thank you, gentlemen, and congratulations, Grand Mechanical Solutions. And now the winner of the commercial category of the Sweet Heat Contest 2021, Rambo Mechanical in Kelowna, BC. Robert?
Yeah, so this hit certainly fired on all the cylinders that I would be looking for from a commercial type project. There was obviously a mention of a standard. In this case, it was LEED. So right away I was looking at, okay, well, what does that mean in terms of the building? So there's obviously some thought that went into the building itself. And then you get into the mechanical systems. And what I really liked about the mechanical systems was the attention to the low temperatures in heating and higher temperatures in the cooling. And that just makes the systems operate again at their peak efficiency. This was a system that was also tied into a central heating plant using geo. So right there, you've got a sustainable system because the power from where this was located in BC is going to be likely hydro. So you have a low entropy power source that's running with heat pumps. So you've got some high COPs, and because it's running on low entropy and low temperatures, you're extracting the maximum amount of work that those machines can do. And it fits really well with the concept that we've been talking about now for many years, including some articles in Modern Hydro or in the HPAC magazine, which is exergy efficiency, and that is matching up load temperatures to supply temperatures. So in this case, they've done a beautiful job of doing that. So that impressed me from an efficiency point of view. The low temperatures, the central plant, the heat pumps, the fact that it's powered likely by hydro. Just all the cylinders are working there, and that's why I gave it the nod for first prize. John?
Can I just back up, guys? Just so we acknowledge, this is a University of British Columbia, Okanagan residence building that was constructed.
Yeah,
Sorry.
137,000 square feet, 6 stories. So nice size project, and clearly some good thought went into the engineering, and then obviously you can tell from the workmanship that was assembled really well as well.
Yeah, the low temperature, the heat pumps, pretty much what I'll echo what Robert was saying here. A lot of state of the art stuff here, the district heating, large heat exchangers, the 6-way control valves. So basically they're going out and they can service a terminal with either chill water or hot water from a single valve body with an actuator on it. So also like the heat recovery function of it, how they're doing the heat recovery from the kitchen exhaust. So it really looked like they were taking advantage of opportunities here to, minimize energy use, and as Robert was saying, use systems that do operate with good exergy, good attention to the exergy concept. So moving forward as we go from predominantly fossil fuel in our lifetime in careers and working with hydronics, certainly that's been the dominant, moving towards decarbonization. Here's a hydronic system that is starting to recognize that. And I shouldn't say starting, it really does a good job of recognizing that electrical based systems and low temperature systems are going to be the certainly the new normal in hydronics, and this system is a good example of that.
Yeah. One of the things that we should point out, they did some really unique things, which I like from an energy conservation point of view. And that is that the windows have magnetic switches on them. So when the students open up the windows, so right away they're allowing for natural ventilation, which is has a lot of benefits. But also when they open the windows, we don't want the mechanical systems running, right? Because that just goes against the whole principles of conserving energy. So the fact that they're disconnecting the mechanical, the ventilation, heating, cooling as the windows open is also obviously somebody's paid some attention to the details on that. So yeah. All right, Doug, let's
That's
get on
awesome.
let's get on to the residential. So
Okay.
congratulations. Yeah.
Congratulations, Rambo Mechanical of Kelowna. Okay, so let's move on to the residential finalists. And our runner-up in the residential category, Denwright Mechanical of Sturgeon County, Alberta. Robert, what was this project?
So we're looking at a residence that had a mechanical system that needed some therapy. And part of it was, due to maintenance and design and installation. And so the folks at Denwright Dennis, who I know, went in and, did their magic on it. What I liked about it, in particular, was somebody, Dennis and his crew, paid attention to, again, return temperatures. Lots of times we see people doing hybrid systems with fan coils and radiant or whatever, and they end up having to run the boiler at a high temperature because the manufacturers publish performance data for their fan coils, typically based on high temperatures, 180, 160 degrees. That doesn't do anything for the efficiency of a boiler. Those return temperatures, in order to extract the maximum amount of work out of those things, you need to get those temperatures down around 75, 80 degree return water temperatures. And the only way you're going to be able to do that is to oversize the heat exchangers on the air handlers. And we actually have wrote about that. There's a, Doug, I don't remember which issue it was, but I talked about the importance of not just defaulting to the manufacturer's literature when it comes to picking fan coils, but to actually look at how can you design or work with their engineers to get those temperatures down so that you can return 80 degree water temperatures at design conditions or lower if you can through the boilers with the air handlers. So I really like that. And of course, all the other sort of attention to the details. So that was my reason for giving it the runner-up for this particular category. John, go ahead.
Yeah, it's he squeezed a lot of stuff into a pretty small space there, and yet retain good accessibility. I'm just looking at it from the standpoint, if I was a service contractor, can I get to the pumps? Can I get to the other devices in the system from a servicing standpoint? It looks pretty good there. One small detail, seemingly very insignificant, over on the far right of where the circulators are, you see that vertical white perforated. Yeah, that's basically it's used in the telecommunications industry. It's a wire raceway for low voltage wiring, and you can see how they've routed the wiring coming out of those zone controls up through there to keep it nice and neat. So it's a nice workmanship detail. We've seen systems where when there's both low voltage and line voltage involved, they'll set up two of those conduits. One will have the line voltage, the other will have the low voltage. The nice thing about that, it keeps the sensor wiring away from the AC wiring. So it's a small detail, but it's a nice detail, and you can see the two zone control units there. He's kept the wiring nice and compact. So I give him a good rating for being able to integrate that much hardware into that space and yet keep it accessible for servicing.
Very good. A common issue we hear is mechanical rooms that are about the size of a bread box. So this one did a great job with what he had.
Yes.
Okay, gentlemen. Now we're ready for the winner in the residential category. Riverdale Plumbing in Toronto. Robert, tell us about this one.
So a new home, large, lots of interesting things going on that we liked about this project. One, it was a hybrid system. So we had heat pumps and boilers as well. Low temperatures again, which we like to see to get those boilers condensing as they should. One of the other key things that, and I'll let John, because this is one of John's favorite stories, but I do want to mention it. And, as we have grown up in the industry 40 years, each of us in the looking at conserving energy through architectural processes, efficiency in our mechanical and electrical systems, compliance with standards that relate to the indoor environment, ASHRAE 55 for thermal comfort, 62.2 for air quality. But one of the other ones, it has to do with the amount of power that we use, consume, convert, if you will, to move water. And what I liked about this particular project is that given the size of the loads, that they really used the least amount of electrical power to move the amount of thermal energy through the building. That impressed me the most out of all of it. The workmanship, again, looks great, and lots of other things, and the size of the project can be impressive, although it's not a criteria for their award for the first place here. It had to do with the fact that a lot of energy, a lot of thermal energy, and they're doing it with the least amount of electrical power. So I'm going to pass this over to John, because John has done a good part of his career promoting that concept. So go ahead, John.
Yeah, we call it distribution efficiency. Very simple idea. It's just taking the BTUs per hour that is being delivered at design load. And here we've got 5 boilers at 400,000 BTUs per hour each. So I get 2 million BTUs per hour. And you divide that by the wattage of whatever equipment has to operate to deliver that energy. And I don't know the exact number here, but as Robert was pointing out, I'm sure it's high. So it's sometimes we call it the untold story of hydronics. I refer to it. Oftentimes we get hung up about, or the industry as a whole gets hung up about, boiler efficiency or heat pump COP. And they use that as kind of a sole criteria to judge the quality of the system. And it really shouldn't be that. It should be looking at not only the energy that's being consumed or converted to produce the heat, but also the energy that's being used to move it through the building. And hydronics is easily a 10-to-1 ratio there over air. So it's a huge advantage. And with good design like this, and I'm looking at these circulators, high efficiency ECM circulators, certainly variable speed. I know the description of the system mentioned using valves rather than zone circulators, which is definitely going to use less electricity. I know that's a pretty touchy topic in North America. Do we have a wall full of circulators? Do we have a wall full of zone valves? And we've got contractors that favor both approaches for different reasons. But from an energy standpoint, the use of a variable speed pressure regulated circulator combined with valves, which is one of the descriptions that was noted on this, is definitely going to use less energy. Obviously, workmanship is beautiful. That hydraulic separator, that's a pretty cool transition from looks like about 3-inch pipe to about 8-inch pipe. I'm not sure where they found that. Probably a custom-made fitting. There's probably enough water in that hydraulic separator to act as a small buffer tank. If it's low temperature, probably not a lot of loss. But if I had to say anything, put some insulation around that hydraulic separator and reduce the heat input to the mechanical room. The diamond plate is beautiful. It must be that's a pretty good price point up in Canada. We see a lot of it in these entries. The tile floor is nice. I'm looking at the condensate drains. A lot of pre-planning went into this. I remember from the description, it was a relatively small space, but obviously, as Robert's saying, it's a very large home here. So again, well done, modern technology, well-placed hardware from a servicing standpoint. Nice looking project.
Yeah. As we sort of talked about earlier, having both of us been judges in contests before, over the decades that we've been looking at these kinds of stuff, there is a theme when we pick these winners, and it's nice to see the workmanship, no doubt about it. But having, like I said, between the two of us, John, 80 years of experience, we've seen a lot of nice jobs, and it's nice to see them, but it's not what it's all about, and sometimes actually, as time has gone on, seeing these great, big, huge residential projects can often cause some cynicism. Certainly in my, and when I look at some of these projects. So when it comes to energy, conserve it first. That means looking at architectural systems first and foremost. That has to be it. If we're going to be doing hydronic systems, well, then you have to get into the interior design to look at conductive flooring, tight tube spacing, all these things drop the temperatures down, which benefits heat pumps, benefits the boilers, and then looking at the electrical efficiency. So, through the filters that I have, those are the things that I look at. Yeah, big projects, we've seen thousands of them, right? And the workmanship, okay. Kudos to those that put in the work, but ultimately, at the end of the day, these projects last, hopefully 50, 100 years. And that means, are we penalizing the owners of these buildings with energy consequences that could have been eliminated by better design and better applications of engineering principles?
Yeah. And just to, again, echo the idea of a long system life. When we talk about, for example, appliances, think about refrigerators, microwaves, even ovens. Go into an appliance store and ask the salesman, will this thing last 20 years, 40 years, 50 years? And, they're going to smile like you are, Doug, because they know it's a planned obsolescence. And yet these systems, at least the distribution aspect of them, could last for many decades. Yeah. Those boilers might be replaced in 20 years or perhaps less. But the low temperature design of the balance of the system would allow that balance of system to be compatible with a heat pump. Or, who knows, 25 years from now, I don't think Robert and I are going to be judging contests anymore.
Probably not.
And I don't know what those heat sources are going to be, but low temperature is a safe bet. I guess I would probably lean towards heat pumps, just given where the markets are going right now in energy. And these systems have, I use the term future proofing. We're building a long system life into it, everything, including as much as we can the heat sources, but recognizing that heat sources like boilers and heat pumps, 20 years is about it on most of the present generation, but 50 years, 100 years, possibly on the distribution system there with reasonable maintenance, water quality, certainly important there. So these systems had those underlying foundations that would allow that future heat source to be compatible.
Gentlemen, John and Robert, thank you again for being the judges for our first Sweet Heat contest. And thank you to everyone who entered, all 31 companies who sent in photos, and of course to our winners who I'll personally be reaching out to get your stories and to get them into print come later this summer. That's it. We're wrapping up the Modern Hydronics Summit 2021. It's been a real success from our point of view. We hope everyone who's watching enjoyed it. And I'd also like to send out another thank you to our summit sponsors, Residio, our registration sponsor, Anvik and Roth, our lunch and coffee sponsors, Cleffy, our keynote session sponsor, and all of our other session sponsors, including Arctic Heat Pumps, NTI, Viessmann, and Klima Veneta, a Mitsubishi Electric company. Thank you all. And also to every one of our exhibiting companies in the virtual exhibit hall. And remember, this is our final scheduled session for this year's summit, but this event site remains open for at least 2 more months. All of the sessions are now on demand, so you can come and view them on your own time. And don't leave yet. The exhibit hall is still open with people standing by. And it's always here, so I encourage you to come back to the Modern Hydronics event, this site, again and again. And that's it. That's a wrap.
Thanks, everybody. Cheers.